All right, let's look at lesson 3.5, parallel lines and triangles. Postulate 3.2 says that through a point not on a line, there is one and only one line parallel to the given line. So if you had a line L and you had a point P above it, you could only draw one line that goes through point P and being parallel to that first line L. So there's exactly one line through P parallel to L. Now let's look at the triangle sum theorem. Most of you guys already remember that the sum of the measures of the angles of a triangle is 180 degrees. So that means if we have triangle ABC, that means the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. One thing to always remember is that A, B, and C are vertices. These are points, and therefore they are going to be capital letters. So remember, your vertices of triangles are always capital letters. So let's take a look at our first example. What is the measure of angle B? So there's a couple ways you can look at this. Okay, you can write this algebraically, and then there's going to be kind of what you know in your head and how you'd set it up. So let's take a look here. First thing, I know that angle A plus angle B plus angle C is equal to 180. So I could come back and say 30 degrees plus 35 degrees plus angle B is equal to 180. Now I didn't go in exactly order here, but the two angles plus angle B is equal to 180. 65 plus angle B is equal to 180. Subtract 65. That gives us that angle B is equal to 115 degrees. So it's 115 degrees. Now, the way I usually work it, okay, if I'm looking for angle B, I know that the sum of my angles is 180. I'm going to do 180 minus that sum. Now I realize we're doing the same thing, but it's kind of the way we think about it. Okay, I'm going to add my two angles up, subtract it from 180. So that's 180 minus 65, which is going to be 115. And that would be the measure of angle B. So both ways to work it, both ways are correct. This is the way you'll see me work it a lot, just because it's just a cleaner and simpler way to do it. All right, so let's take a look at the next one. Now we have a situation where we have three triangles, and we have angles that are going to be a part of several triangles. We have adjacent angles, we have linear pairs. So it asks us to find what is the measure of angle X, of X, Y, and Z. What is the measure of these three variables? Well, I have triangle ADB. I have two angles in that angle and angle X. In triangle BDC, I have a Y, a Z, and 49 degrees. And then in the entire triangle, I have A, which is 59, C, which is what we're looking for here, and then B is going to be the sum of these two here, which would be 92. So let's start with X. X is equal to the sum of these two angles subtracted from 180. So that's what we're going to do. 180 minus 43 plus 59. So 180, add these two up here, and that's going to give us 102. And 180 minus 102 is going to give us 78. So X is equal to 78 degrees. So we'll put that in over here, 78. Pencil that in. Now one thing to note is how we find Y. Well, Y is a linear pair with X. These form a straight line here. AC is a straight line. So therefore, these are a linear pair, which means they're going to be supplementary. So that means to find Y, I'm going to take 180 and I'm going to subtract out the angle X, which is 78. And that's going to give me that Y is equal to 102. So these are very similar related. And then for Z, we're going to work it the same way we did X. So Z is equal to the other two angles. We said Y was 102. So it's going to be 180 minus the sum of 49 plus 102. Add these up, that gives us 151. And z is going to be equal to 29. So x is 78, y is 102, and z is 29. And then we found all our three missing variables. You can always go back and double check to make sure everything adds up to 180. This triangle equals 180, this triangle should equal 180, and the entire triangle should equal 180. All right, so let's move on to the next one. You guys give this one a try. So pause your video, work this one out, and come back and check to see how you did. All right, so once again, we're going to start with saying that x is equal to 180 minus the sum of these two. So 32 plus 46 is 78. 180 minus 78 is 102. Y is going to be a linear pair with x, so that means that 180 minus 102 is 78. So we had 102, 78, and then to find z, we're just going to take 180 minus the sum of 36 and 78, and that gives us 66. All right, so let's keep moving. So now I want you to apply the triangle angle sum theorem to find the measure of x and then find the measure of each angle. So as we set this up, one thing you want to remember is that angle R plus angle S plus angle T is equal to 180. Substitute your expressions in for R, S, and T, solve for x, and then plug it back in to find your angles. So pause the video again, work this one out, and come back and see how you did. All right, so as we set this up, we have 7x minus 13 plus 2x plus 2 plus 4x plus 9 is equal to 180. 7x and 2x and 4x give me 9 plus 4 is 13, and negative 13, positive 2 is a negative 11, negative 11 and a positive 9 is a negative 2. Add the 2, get 182, divide it by 13 and get 14. So now we go back and have to plug it in. We get angle R is 85, angle S is 30, and angle T is 65. All right, now let's look at this one. This one's a little different. The measure of one angle of a triangle is 60. So we have two other angles we got to find. The ratio of the angles is 7 to 8. Find the unknown angles. So the way we set this problem up is we start off with 60 plus 7, and we're trying to figure out what number can we multiply by 7 and 8 so that when we add it to 60, it equals 180. So this becomes 7x and 8x. So now we work it like a normal algebra problem. We have 60 plus 15x. Subtract 60. $15x is equal to 120, and divide 15 into 120. That gives us x is equal to 8. So now it asks us for the measure of the two unknown angles. That's going to be 7 times 8, which gives us 56. And the other one is going to be 8 times 8, which is going to give us 64. So our two unknown angles are 56 degrees and 64 degrees. If you add up 56, 64, and 60, it should equal 180 degrees. All right, triangle exterior angle theorem. So the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So to understand what the remote interior angles are, an exterior angle is formed by extending one of your sides of your triangle. So if we extend this out, it forms an exterior angle. Angle 1 is supplementary with this adjacent angle that's inside. So that means that angle 1 is equal to the sum of angle 2 plus the angle of 3. So we'll look at that over here. Angle 1 plus angle 2 plus angle 3. Or angle 2 plus angle 3 is equal to angle 1. Okay, it's not equal to 180. It's the number outside is equal to the 2 on the inside. So if we go back and kind of show you how this works, if we go back and look at this problem here, we could found y at the beginning because y would be equal to 32 plus 46. If you add 32 and 46 together, we get 78, which is what y was. And so once we found that 78, we could subtract from 180 to get 102. So that's another way you could have solved this, by finding y first, and then you can find x. And then z, you could do the same thing. This is 102. 36 plus z is equal to 102, so I would subtract 36 from 102, and that's going to give me 66. So that's the second way. That's just another way to work this problem, using the exterior angle theorem. So it's kind of a shortcut. All right, so let's take a look here at our first example with using the exterior angle. So example 3. Looking for angle 1, we're given that 80 degrees and 18 degrees. So angle 1 is equal to the sum of 80 plus 18. Angle 1 is equal to 98. And it's just that easy. The angle on the outside is equal to the sum of the two remote interior angles. So, like I said, this is 98. Now you could also find the measure of this interior angle by subtracting it from 180. That would give you the angle on the inside. All right, so you guys try this next one. Pause the video, come back and check your work when you're done. All right, so we take 124 equal to the sum of 59 plus whatever angle 2 is. So 124 is equal to 59 plus angle 2, subtract 59 to get 65. Angle 2 has to be equal to 65. Double check it by adding 59 plus 65 to see if it does in fact equal 124. All right, so let's take a look at this one. Now they give us a variable expression for our exterior angle. So if you look here, we've got our exterior angle, angle SRP, is equal to 23 plus angle Q, which means it's going to be, instead of putting 23, we'll say angle P plus angle Q. So now we can go back and plug these in. Angle SRP is referring to this measure from here all the way to here. So we take 9x plus 2 equals 23 plus 5x minus 1. So now we're going to simplify everything on the right, combine like terms. So 22 plus 5x equals 9x plus 2. We're going to subtract our 5x. 4x plus 2 equals 22. Subtract 2. 4x is equal to 20. Divide by 4. And x is equal to 5. So once we found that, it's a matter of going back and plugging it in. So the measure of angle SRP, this one here, is going to equal 9 times 5 plus 2. So 45 plus 2 is 47. So this angle out here is 47 degrees, which means these two should also equal 47 if you add them up. So now, we'll take, we know angle P, so we got angle Q to look at next. That's going to be 5 times 5 minus 1. So 25 minus 1, and angle Q is equal to 24. So if this is 24, this is 23, add them together, that gives me 47, which is what we got here. So if it helps you set up the exterior angle theorem, write the angles that are going to be equal to each other, that you add up to set equal to your exterior angle. All right, let's take a look at our last example. When a radar tracks an object, the reflection of signals off the ground that can result in clutter. Clutter causes the receiver to confuse the real object with this reflection, called a ghost. So the airplane at D is called the ghost. At the right, there's a radar receiver at A, an airplane at B, and the airplane's ghost at D. What is the value of X? Well, if you look here, see what information they give us in the picture. We have an exterior angle here. We have two remote interior angles. That means that angle 80, 80 degrees is equal to the sum of 30 plus x. Subtract 30, and x is equal to 50. So 50 degrees over here at angle A. You can double check it by doing 50 plus 30 to get 80, and that is correct. And that concludes lesson 3.5.